Hello and welcome to this channel. Today we are going to discuss about electric field due to uniformly charged straight wire. If a wire is like rod or any straight wire on which charge is distributed uniformly throughout the length of the wire, and we want to find electric field at a point which is at a distance r from the wire, and this distance is perpendicular, of course, to the wire. So in this case, what we can do is we can consider that, let us say that there is one wire on which charges are there, like plus charge or minus charge, anyone we can consider. So now due to this wire, we want to find electric field at a point which is, let us say, at a distance d. This point P here we want to find electric field, right? Now we take one random point. So angle made by this line joining the point and wire, let us say this angle is theta 2, and angle made from the another end of the wire, so this angle is, let us say, theta 1. So in this direction we can consider angles. So we have considered that there is one wire and charge density, of course linear charge density, that is lambda on the wire, right? So this is condition which will be given in the question, or we can consider that wire is there and we have to find electric field at this point P. So now how we can do? In this case, now if you consider that general formula E, that is equals to KQ divided by R square, but here problem is charge is not the point charge, and if you consider any one point, suppose if you consider this point, so from here now if you consider, so electric field will be in this direction, and distance is also of course changing at different points. So in these kind of questions, what we can do is we can consider one small element at a height of y, and then due to this element we can find the electric field and then do the integration. Simple. So here now we have one wire in which lambda is the charge density. So we consider one element at a distance of y from the line joining the wire to the point, and at this point we want to find the electric field due to this small element dy. So can I say that dq means charge due to this small element, that will be equals to lambda times dy, right? Now we can write electric field due to this small element d, so that will be equals to k dq divided by this distance, let us say this distance is r. So k dq divided by r square, right? Now dq we can write as k lambda dy divided by r square. So now we can find the electric field due to complete wire by doing the integration. So here now angle is also changing for DE for different elements. So we have to break the angles in two parts, as well as here the problem is R is changing for different points, and so length Y will also be changing. So here now we need to first simplify the R and Y in terms of theta and given distance D. So if you consider this angle, so can I say that tan theta, tan theta, that will be equals to how much? Y by D. So from here, can I say that Y will be equals to D tan theta, right? So now if we do the partial differentiation, so we can write dy, so that will be equals to D is constant here, and tan theta will become equals to sec square theta d theta, right? So dy we got in terms of d and theta. Now similarly, if we consider cos theta, so can I write cos theta from the same triangle? So cos theta, that will be equals to d by r. So from here now can I say that r will be equals to d upon cos theta, or can I write it as d sec theta, right? So now we can put the values in d. So now we can write dE, so that will be equals to k lambda, and dy we can write as dy will be equals to d sec square theta d theta, this is dy divided by r square, and r here is d sec square theta, so d sec theta, so d square sec square theta. So this sec square theta, this sec square theta we can cancel. 1d also we can cancel, and this is d theta, not d. We cannot cancel this d, right? So from here now we have dE, that is very simple expression we got, which is equals to k lambda by d into d theta, right? Now we can break this d in two parts. One is along the line which is parallel to the wire, that is called as DE parallel, and one which is perpendicular to the wire, that is DE perpendicular, DE cos theta. We can break in two parts, right? So now we can simplify. So let us see. So we got DE, so that was equals to k lambda by d into d theta. So now we can write E parallel, that will be equals to integration of dE sine theta, right? And now theta is from where to where? So see, this is our line, and when we move in clockwise direction, so this is theta 1, and when we move in anti-clockwise direction, that is theta 2. So here angles are different, so we cannot say that this is the same angle, so we cannot write like this. It is not working. Okay, right? So here now what we can do is we can take theta, limit is from minus theta to opposite direction to theta 1. So we can put the value. So we have k lambda by d, that is constant only, and we have integration of sine theta d theta from minus theta 2 to theta 1. So this we can write as k lambda by d, and integration of sine theta will be what? Minus cos theta, right? So we can write minus cos theta from minus theta 2 to theta 1. So this we can write as k lambda by d, and cos theta or cos minus theta, that is cos theta only, right? So this we can write as cos minus, or we can remove this limit by changing it. So we can write it as cos theta 2 minus cos theta 1 minus sign it adjusted. So we got E parallel. Now similarly we can write E perpendicular. So that will be equals to, let us change the color so that it should be clear. So E parallel now we can write. So it will be equals to again d cos theta, right? E parallel. So we can write integration of de cos theta from minus theta 2 to theta 1. So now I can put the values. So k lambda by d, that is constant only, charge density is not changing, neither the distance, so we can take it out, and cos theta d theta, again limit is from minus theta 2 to theta 1. So now put the values. So this we can write as k lambda by d. Now integration of cos theta will be equals to sine theta from minus theta 2 to theta 1. So this we can write as k lambda by d sine theta 1 sine theta 1 minus of sine minus theta 2. And we know that sine minus theta is minus sine theta. So minus minus will become plus. So we have E perpendicular, that will be equals to k lambda by d, and this will become sine theta 1 plus sine theta 2, right? So this will be our final answer. So we can conclude that electric field due to finite uniformly charged straight wire. So in this case, E perpendicular, that will be equals to k lambda by d sine theta 1 plus sine theta 2, and E parallel will be equals to cos theta 2 minus cos theta 1. And here theta 1 and theta 2 are measured from the perpendicular line in opposite directions, and lambda is linear charge density. Suppose if q charge is given, so we can write lambda, that will be equals to q by L. So if you want, you can put the value of lambda here and we can simplify. No issue in that, right? Okay. So now there are some special cases in case of uniformly charged wire. The cases may be if the wire is infinitely long, semi-infinite long. So what is semi-infinite long? Suppose one case we will consider all the cases. So here now we have electric field due to semi-infinite uniformly charged straight wire. So your wire is a straight wire, and we know the one end of a rod, another end we don't know. So length, when we say infinite, it doesn't mean that the wire is from Earth to infinite, means up to Sun or anywhere. Here it means that the length of the wire, suppose length of wire is L, and this separation of the point where we want to find the electric field, that distance D is very small compared to length of the wire. So, and if it is near the one end of the wire, so we consider it as semi-infinite wire, right? This point is clear. So now here we can say that theta 1, so if you consider the wire is semi-infinite, so if you consider one angle, so as the length of the wire is changing, you can see here, so as the length of the wire is increasing, this angle is also increasing. So if wire is up to infinite, so this angle will be almost straight, right? So this angle will be how much? 90 degree. So theta 1 will be how much? 90 degree. And theta 2 will be how much? If the point is in front of wire, it is 0 degree, because this line is making angle how much? 0 degree from this end. If point is somewhere, so that angle will be given, we can take that. So theta 2 will be how much? 0 degree, right? So now we have formula E perpendicular, that is equals to K lambda by D sine. These are simple formula you must be knowing, sine theta 1 plus sine theta 2. So we can put the value, sine 90 is how much? 1, sine 0 0. So we can write it is K lambda by D. Similarly we can write E per parallel, so that will be equals to K lambda by D cos theta 2, angle gets changed, cos theta 2 minus cos theta 1. So again cos theta 1, cos 90 is how much? 0, and cos 0 is how much? 1. So this is equals to how much? K lambda by D. So here now we got two electric field which are equal in magnitude and at angle 90 degree, right? So we can write E net, so its magnitude if I write, so that will be equals to root under of K lambda by D means E perpendicular square plus E parallel square. So if you simplify, this will become equals to how much? K lambda by D root 2, right? Simple, easy. Now, similarly, we can take another case. So here now magnitude of electric field, we can write E net at the point P, that will be equals to K lambda by D root 2. Now next is electric field due to an infinitely long uniformly charged straight wire. So when we have wire which is infinitely long, means the both ends of the wire are at very far distance from the point P, means the distance is very small compared to length of the wire. So here now again we can say that theta 1 will be equals to how much? 90 degrees. See, if you have confusion, we can take one small wire. At this point, if you consider, so these angles, if length of the wire is increasing, this angle will be increasing. If it becomes infinite, angle will be how much? 90 degree, right? So theta 1 is 90 degrees. Similarly, theta 2 is also how much? 90 degree. So now we can write E perpendicular. So that is equals to K lambda by D sine theta 1 sine theta 1 plus sine theta 2. So theta 90 means 1, 1 plus 1 is how much? 2. So we can write 2K lambda by D, E parallel. Similarly, we can write E parallel, that will be equals to K lambda by D. Now we have cos 90 degree minus cos 90 degree, right? So that will be how much? 0. And of course we know that if angles are same, then cos theta minus cos theta will be how much? 0 only. So for the points which are symmetric to the wire, means of same length on both side or angle is same, in that case at that point electric field will be only along the perpendicular and parallel will be how much? 0, right? So net electric field we can write E net, so that will be equals to 2K lambda by D. Now whenever charge is symmetric, we can use the Gauss law also. that we will see in next another video sometime. Now there are some more cases, like suppose if the point is not in front of rod, point is not in front of rod. Like suppose this is one rod and point is here, somewhere here. So now what we can do, and this angle will be given to you. So in that case, what we can do is, again we can apply the superposition principle, like where there is nothing plus minus we can assume and then we can solve. So let us say this angle was beta and this angle was alpha. We have considered from the perpendicular line. This length is of course d and wire has charge density as lambda, plus lambda, charge is distributed. So now in this case what we can do is we can consider theta 1 that is equals to alpha and theta 2 will be equals to minus beta. Or if you consider how much angle is made by this one end of the rod on this, so it will be like this, we can consider, right? So that angle will be how much? 360 minus, so that will be equals to 360 degree minus beta. So that will be minus beta only for any angle. So here now we can write E perpendicular, that will be equals to k lambda by d sine theta 1 that is alpha plus sine theta 2 which is minus beta. So it will become what? Minus sine beta. Or we can see alpha angle when we consider, so this beta angle which where rod was not there, this part also we have considered, right? So that part we have to eliminate, so minus sine beta, like this we can remember. Similarly we can write E parallel, that will be equals to k lambda by d. Now cos minus theta is cos theta only, so we can write cos beta minus cos alpha, right? Like this we can solve. So this is all from this video. Next time we'll see another concepts. Okay, bye bye.